Hello everyone. Here we are going to study the performance of short transmission line. Consider an equivalent circuit of short transmission line which consists sending end voltage Vs, receiving end voltage Vr, sending end current Is, receiving end current Ir, which are per phase quantities. Also, R is the resistance per phase, X is the reactance per phase. Hence, the total impedance of the circuit is represented by Z per phase. For short transmission line, we generally neglect the capacitance. Now, for this circuit, let us draw the phasor diagram. Consider first VR as a reference. So, this is a VR as VR is the receiving end voltage which is across the load. For the load, generally the loads are of inductive in nature, hence the current passing through load is considered as IR, which is lagging in nature. Voltage drop across the resistance is given by IR into R. The voltage drop across the reactance is right angle triangle to voltage drop across R, which is IR into X. The equivalent of this triangle is represented with IR into Z, and the total voltage of this is represented with the voltage Vs, where the angle between IR and VR represented with the angle phi r. The angle between IR and Vs represented as a phi s. If you consider equivalent circuit, here it is clearly observed that the sending end current Is is equal to receiving end current because it is a simple series connected circuit. So IR is equal to Is is equal to I. Hence, the angle between this IR or Is to the Vs is represented with the phi s, and angle between VR and IR represented with the phi r. Now, this phasor diagram is drawn by considering VR as a reference. Let us draw the phasor diagram by considering IR as a reference. I is equal to IR is equal to Is. Now, the voltage across receiving end or load is represented with the VR. The voltage drop across resistance is represented as a I into R. Voltage drop across reactance is represented with I into X, and the total voltage drop across impedance is I into Z. If we draw the resultant of this voltage drops, we will get sending end voltage. Let us consider it as a Vs. Now, for this figure, I will give the names as O. Here, I can draw the perpendicular lines for simplification purpose only. So, this is D, C, B and E. To determine the value of Vs and Is, consider this phasor diagram. As we know, Is is equal to IR is equal to I. So, this is equation number 1. Now, for finding Vs value, apply Pythagoras to triangle ODC. Here, OC square is equal to OD square plus DC square. Hence, OC becomes equal to root OD square plus DC square. Now OC is nothing but VS is nothing but OD can be written as OE plus ED bracket square plus DB plus BC bracket square. Now to determine the value of these parts, let us consider the triangle OEA. Here we can consider triangle OEA. This is nothing but VR, this is phi r, and this is I. So cos phi r and sin phi r becomes equal to OE upon VR. Hence OE can be written as VR cos phi r. So consider OE can be written as VR cos phi r plus ED. ED is nothing but IR, which is parallel line bracket square plus DB can be written from this again triangle. Sin phi r is equal to AE upon VR. Hence AE can be written as equal to DB. Hence VR sin phi r plus BC can be written as I into X bracket square. So using this formula, we can calculate sending end voltage Vs. For this, by using this Is and Vs, we can calculate the parameters. Power factor at sending end voltage cos phi s can be calculated using this triangle ODC. For ODC, cos phi s is equal to OD upon OC. As we know, OD can be written as VR cos phi r plus I into R upon OC as a Vs. So this is the power factor at sending end voltage. We can calculate the percentage voltage regulation by formula Vs minus VR upon VR into 100. This is equation number 3. And percentage transmission line efficiency as output power upon input power or output power upon output plus losses. Hence, we have the values of output power as a VR, IR, cos phi r upon output power same VR, IR, cos phi r plus losses. So losses takes place as a I square R into 100. So this is the equation number 4. Using equation number 1, 2, we can calculate sending end current and sending end voltage respectively. And using equation 3 and 4, we can calculate percentage voltage regulation and percentage transmission line efficiency. Thank you.